So we have another question on the board, still on the friction, an important topic in physics. The question says horizontal force of 45 Newton applied to a crate of mass 9 kilogram. The horizontal force of 45 Newton applied to a crate of mass 9 kilogram is just sufficient to move it. Okay, so let's look at that first statement. Horizontal force of 45 Newton applied to a crate of mass 9 kg. So we assume that this crate, which is a block, the block is placed on a horizontal surface. Okay, so they made mention of a horizontal force. So to this block, we have a horizontal force applied to it. That effort that pulls it is 45 Newton. So horizontal force of 45 Newton applied to a crate of mass. And the mass of this crate is 9 kg. That means it will have a weight. The weight will act vertically downwards, and the weight is equals to mass times acceleration due to gravity. Okay, now the mass is what? 9 kg. It was stated in the question, a mass of 9 kg. Okay, that is 9 kg times acceleration due to gravity is 10 meters per second square. That is times 10 meters per second square. Okay, so if I multiply that, that is 9 times 10 will give me 90. I'm having 90 Newton. The weight is equals to 90 Newton. All right. Okay, so the weight of that block is 90 Newton. Now I will then look for the normal reaction. The normal reaction will be normal reaction is arrow. Normal reaction is arrow. So arrow is this, acting at 90 degrees. Acting at 90 degrees, I have my normal reaction. Okay, and if this block is moving this way, if the block is moving this way as a result of the friction force, then as a result of the effort applied, the block is moving towards the right. Friction force will act opposite the direction of motion. That means it will act opposite direction of motion. Friction force will act towards the left. Okay. All right. So that is it. So if this is motion, the direction of motion. Say direction of motion. Direction of motion. The friction force must act opposite the direction of motion. That is, it will go this way. If motion is going towards the right, friction force will go towards the left. It must counterbalance what? Relative motion. Okay? Must counterbalance relative motion. Okay, then we have gotten that. Now the next thing we will then look at, we take the upward force equals to the downward force. You see upward force. This is it. You see upward force equal to upward force equal to downward force, and the upward force there is arrow, our normal reaction. So you see arrow equal to my downward force is W, which is my weight. So the upward force is the normal reaction arrow, and the downward force is the weight, 90 Newton. Okay, so that means that arrow, so therefore arrow will be equals to 90 Newton. Okay, so my normal reaction is 90 Newton since W is 90. Okay, now the next thing I'll look at is the right hand force equals to the left hand force. So you see right hand force equal to left hand force. So my right hand force is E. My left hand force is friction, F. Okay, so my right hand force is E. The left hand force is friction force, F. So E will be equals to F. Alright, and the value of E is what? 45. So you can also see 45 is equals to F. Therefore, my friction force is what? 45 Newton. Okay, my friction force. So frictional force is is 45 Newton. Okay, now hence I've gotten the frictional force as 45 Newton. I can then go back to the formula for coefficient of friction. That coefficient of friction mu is equals to friction force over normal reaction. That's coefficient of friction equals to friction force over the normal reaction. Okay, so I'll find my coefficient of friction. Which is mu will be equals to the friction force is 45 Newton divided by the normal reaction. We had the normal reaction as 90 Newton. Do not forget that. We had it as 90 Newton. Okay, so remember we had the normal reaction R as 90 Newton, and then we had the friction force F as 45 Newton. We had the friction force as 45 Newton, and my normal reaction as 90 Newton. Okay, so 45 divided by 90, let's look at that. 45 divided by 90, that's 45 go here 1, go here is 2. Okay, so 45 into 90 is 2, and 1 divided by 2, friction force is 1 over 2, which is equals to 0.5. So my coefficient of friction, this implies that the coefficient of friction is equals to 0.5. It has no SI unit. Coefficient of friction has no SI unit. Take note. It has no SI unit, so mu is equals to 0.5. Okay. Now we'll come back to this question. It says if the crate is now pulled at an angle of 50 degrees to the horizontal, find the force required to move the crate over the horizontal surface. So in the next case, the crate is pulled at an angle. It is pulled at an angle of 50 degrees to the horizontal. So we assume this to be the pull, an angle of 50 degrees to the horizontal. It is pulled at an angle of 50 degrees to the horizontal. So find the force required to move the crate over the horizontal surface. So we are looking for this force. Now you will resolve this way and this way. Resolving it horizontally, you have px equal to p cos 50 degrees. Okay, and resolve it vertically. Resolve this force vertically. You have py equal to p sine 50 degrees. So resolving this force horizontally like this is p cos 50 degrees. Resolving it vertically like this is p sine 50 degrees. Alright. Okay, so we have done that. Now we also look for the weight of the block. The weight of the block must act vertically downwards. Remember we had the weight as 90 Newton. Very important. We had the weight as 90 Newton. Then we'll find the normal reaction. Okay, find the normal reaction. Now do not take the normal reaction as 90 again in this case. Okay, we'll have to resolve it properly. We'll do a proper resolution. Okay, and since you are resolving this one this way, if you are resolving this force this way, now if it is going in this direction, frictional force will act in the opposite direction. Frictional force must act in the opposite direction. You say F. Frictional force must act in the opposite direction. And we know that F is equals to what? Mu arrow. And its frictional force is coefficient of friction times normal reaction. Okay? Alright. So what we'll do now, we'll take all the vertical forces, and take the horizontal forces. The vertical forces are this upward vertical forces, and this is the downward vertical force. Then we'll take the horizontal force, this and this. Okay? So you say upward vertical force, that is the upward vertical force equals to the downward vertical force. So you say upward vertical force equals to the downward vertical force. Okay, so the upward vertical force, there are two upward vertical forces arrow and py. So this is arrow plus py is p sine 50. That is p sine 50 degrees is equal to, as arrow plus p sine 50 degrees, because so the downward one is w, which is w, the weight. Okay. Alright, so arrow will be arrow plus p sine 50 degrees. You check sine 50 degrees on your calculator. Sine 50 degrees is 0.766. Is equals to the weight is 90 Newton. So multiply this p times 0.766. You have arrow plus 0.766 p equals to 90. Alright, so you can call this one equation 1 if you want. Call this equation 1. Then we come over to this, the horizontal forces. Look at this. Say right equals to the left, or say left equals to right. Okay, so we say the left hand force equals to right hand force, and the left hand force is what? So I'm pointing this way is what? The left hand force, which is F, which is the left hand force, is equals to the right hand force, is this one, that is P cos 50. P cos 50 degrees. Okay, so the left hand force equals to the right hand force, P cos 50. Alright, so F is equals to P cos 50 degrees. Alright, and cos 50, checking on your calculator, cos 50 is 0.643. Okay, so multiplied by P, this is P open bracket 0.643. Now the value of friction force F, this friction force F is mu arrow. This is mu arrow. This is mu arrow equal to P times 0.643. Now multiply it. This will give me 0.643 times P. Okay, and the value of arrow is unknown, and the value of mu, we had mu at 0.5. Remember, mu is 0.5. That is mu here. Mu, the coefficient of friction is 0.5. Coefficient of friction is 0.5. So coefficient of friction is 0.5. This is 0.5 times arrow is 0.5 arrow. Okay, the coefficient of friction is 0.5. So this is 0.5 arrow. All right. Then we can then choose to make arrow the subject of formula. Making arrow subject of formula, you have that arrow will be equal to 0.643 p divided by arrow by 0.5. That is, we divided by the coefficient of arrow, that's dividing by this 0.5, and we have that arrow will be equal to, if I divide this by this, so 0.643 divided by 0.5 is 1.286 multiplied by p. That's 1.286 p. So 0.643 divided by 0.5 is 1.286. So I call this one equation 2. So if I substitute, say substitute equation 2, substitute equation 2 into equation 1, and then you go back to equation 1. This is the value of equation 1.